Hello friends, welcome to this part. In this part, I will try to solve some other gate problems. So this is question number 43. This question came in gate 2016, set number 6, and it is related to AC to DC conversion. So we have a single phase thyristor bridge. Rectifier is fed from a 230 volt 50 hertz single phase AC mains. So let us draw schematic of single phase thyristor bridge. And it is fed from single phase AC source. If it is delivering a constant DC current of 10 amp at a firing angle of 30 degree. So the load is constant DC current source of value 10 ampere. Then value of the power factor at AC mains. So we have to find the power factor of AC mains. So let us name the thyristors. This is T1. Let's say it is T4, T3 and T2. The output voltage is V0. Output current is I0. So this is 230 volt RMS 50 hertz single phase AC source. Let's name it VAC and the current is IAC. So we have to find the power factor of AC mains. So we know that power factor is equal to real power divided by VRMS into IRMS. So for AC source, we have to find what is the real power we are taking from this AC mains. So if you consider the thyristor to be ideal, then the real power which is taken from the AC mains is equal to the real power consumed by the DC current source. So the real power consumed by the DC current source is I naught and V naught average. Because I naught contains only DC component, so we have to consider DC component of the output voltage only. Divide by VRMS into IRMS. So it is nothing but VAC RMS into IAC RMS. So this is the power factor expression. So we know I naught. Now V naught average we have to find. We know VAC RMS and IAC RMS we have to find. So let us take a quick look on the circuit operation of single phase thyristor bridge. And also note that firing angle for this thyristor is 30 degree. This is given in the question. So when T1 and T4 are conducting, the equivalent circuit is, so T1 is conducting, T2 is in off state, T3 is in off state and T4 is conducting. And this is VAC. Let's say this current is IAC. This is V naught. This is I naught. So now we have to find VAC and V naught when T1 and T2 are conducting. So please notice that the current flow path is something like this. It will go through T4, through AC mains, and through T1. So you note that IAC is equal to I naught, which is 10 ampere. And if you apply KVL in this loop, so we have minus VAC and plus V naught is equal to 0. So V naught is equal to VAC. Similarly, we have to find what is IAC and V naught when other two thyristors are turned on, that is T2 and T3 are conducting. So when T3 and T2 are on, so equivalent circuit is, so T1 is off, T4 is conducting, sorry, this is T2, T2 is conducting, and T4 is off. This is VAC, VAC. So when T3 and T2 is conducting, so the path of the current is, it will flow through T3 and back to T4 through AC source. So you can notice that IAC is equal to minus I naught is equal to minus 10 ampere. And if you apply KVL here, minus VAC minus V naught is equal to 0. So V naught is equal to minus VAC. So let's summarize. So when T1 and T4 is on, IAC is equal to I naught and V naught is equal to VAC. And when T2 and T3 are on, IAC is equal to minus I naught and V naught is equal to minus VAC. So let us draw some waveforms to calculate V naught average and IAC RMS. So x-axis is time axis. So VAC is sinusoidal signal. This is pi, 2 pi, V max. So Vm is equal to root 2 into 230 volt. Similarly, you can plot minus VAC, which is negative of VAC. So this is minus VAC. The firing angle is 30 degree, that is pi by 6. This is pi by 6. This is pi plus pi by 6. So from pi to pi by 6 to pi plus pi by 6, T1 and T4 is on. Here you are triggering T1, T4. And you are triggering T3, T2 at pi plus pi by 6. So from here onwards, so up to 2 pi plus pi by 6, T2 and T3 are on. And also here from 0 to pi by 6, T2 and T3 are on. So let us draw V naught. So when T1 and T4 are conducting, V naught is equal to VAC. So this is pi. And when T2 and T3 are conducting, V naught is equal to minus VAC. And from 0 to pi by 6, T2, 3 are conducting, so V naught is equal to minus VAC. So this is the output voltage waveform. So similarly, we have to plot IAC. So when T1 and T4 is conducting, IAC is equal to 10 ampere. and when T2 and T3 are conducting, IAC is equal to minus 10 ampere. Now we have to find what is the average value of V naught and IAC RMS. So this thing we need to calculate what is the power factor. So we can write V naught average. So V naught has a period of pi. So 1 by pi 0 to pi V naught into dt. Or you can write, so from 0 to pi by 6 V naught is equal to minus VAC, that is minus Vm sin omega t, and from pi by 6 to pi V naught is equal to VAC, that is Vm sin omega t into d omega t. So you can take Vm outside, Vm by pi. So integral of minus sin omega t is cos omega t, 0 to pi by 6, and integral of sin omega t is minus cos omega t, pi by 6 to pi. So Vm by pi, so cos pi by 6 is root 3 by 2 minus 1. So this 1 and minus 1 will cancel out. So you have average value of root 3 Vm by pi. Similarly, you have to find what is the AC RMS value. So it is a square wave. So the RMS value will be equal to 10 ampere. So IAC RMS is equal to 10 ampere. So power factor is equal to V naught average, that is root 3 Vm by pi, into I naught average, that is 10 ampere, divided by Vrms. So Vrms is through 30 volt, into Irms, that is 10 ampere. So root 3 Vm is nothing but root 2 into Vrms into 10 ampere divided by pi into 230 into 10. This will cancel out. So if you calculate root 6 by pi, you will get 0.779. So this is the answer for this question. So this is question number 50, and this question came in GATE 2016, set number 6, and this question is related to inverter circuits. So we have a single phase full bridge voltage source inverter is fed from a 300 volt battery. So let us draw a schematic of single phase inverter. These are anti-parallel diodes of each switch. These are output terminals, and it is fed through 300 volt battery. So let us name all the switches. This is S1. Let's say it is S4, S3, and S2. So a pulse of 120 duration is used to trigger the appropriate devices in each half cycle. So we have to find the RMS value of the fundamental component of the output voltage. So this is output voltage. First we have to find what is the fundamental component in the output voltage. After that we have to find its RMS value. When S1 and S4 are on, so your output voltage will be equal to 300 volt. and when S3 and S2 are on, so output voltage will be equal to minus 300 volt. So let us take a look at the gating signal of PSI. So this is time axis omega t. Let's take gate signal of GS1, GS4. So we are turning GS1 and GS4 simultaneously. Let's say this is pi and this is 2 pi. So in question it is given that we are turning the switches for 120 degree in each half cycle. And for GS3, GS2 is, so this is pi by 6 and this is pi minus pi by 6. So total duration is 120 degree here. Similarly here this is pi plus pi by 6 and this is 2 pi minus pi by 6. So let's plot output voltage. So when GS1 and GS4 are conducting, output voltage was equal to 300 volt. And when GS3 and GS2 conduct, output voltage is equal to minus 300 volt. So now we have to find what is the fundamental component of this output voltage, and after that we have to find its RMS value. So now you have to use Fourier analysis to calculate the fundamental component output voltage. So you can see that this wave output voltage has half wave symmetry, so it will contain only sine term, sine and odd terms. So you know that sine term coefficient is 2 by t, 0 to t, your signal ft into sine n omega t dt. Or you can write, signal is half wave symmetry, this integral reduced to 4 by t, 0 to t by 2 ft sine n omega t dt. So let's apply this formula to v naught. So for v naught you can write 4 by, so time period is 2 by pi, 0 to pi v naught sine n omega t d omega t. Or you can write 2 by pi, so from pi by 6 to pi minus pi by 6, v naught is equal to 300 volt into sine on omega t into d omega t. As we are interested only in the fundamental component, so we can put n is equal to 1. So a1 is equal to 2 by pi, 300 you can take out of the integral. So integral of sine and omega t is equal to minus cos omega t. Limit will be pi by 6 to pi minus pi by 6. We can write a1 as 2 by pi cos of pi by 6 . So fundamental component is equal to a1 sine omega t. equal to 600 pi root 3 sine omega t. So fundamental RMS value will be 600 root 3 pi root t. So if you solve this, you will get 233.9, and this is the answer for this question. So this is question number 19. This question came in GATE 2016, set number 8, and it is related to AC to DC conversion. So we have a three-phase diode whose rectifier is feeding a constant DC current of 100 amp to a highly inductive load. So let us draw a schematic of diode, three-phase diode with rectifier. As the output load is highly inductive, so we can assume output current to be constant and its value is 100 amp. You have to draw three-phase AC source. Let's say this is A phase, B phase, C phase, and we can name it as VAN, BBN, VCN. So this three-phase source is balance one. So it means that they have equal magnitude and phase shift of 120 degree. So this is VAN, VBN, VCN. So if three-phase 415 volt 50 Hz AC source is supplying to this bridge rectifier, then the RMS value of the current in each diode in ampere. So we have to find the RMS value of the current in each diode. So let us name this diode. Let's call it D1, D3, D5, D4, D6, D2. So we have to find the current in each diode, and after that from that you can calculate the RMS value. So in this problem I will probably uh, sketch the current through the D1 diode, and once we get the waveform of ID1, we can easily calculate the RMS value of it. So let us draw three-phase AC source waveform. So these interval are of 60 degree. So it's 2 pi by 3. This is pi. This is 2 pi. So let's draw VAM. This is VAN. Similarly, draw VBN. This is VBN. Now we need to draw VCN. So I have drawn three-phase AC waveform for up to 2 pi by 3. So this will be 4 pi by 3 and it is 5 pi by 3. So this is three-phase AC voltage waveform. So now let us sketch what is ID1. So please notice here, if you see above three diode D1, D3 and D5, they have common anode terminal. Okay, so the diode which will have highest cathode potential, this will conduct. So if you look here, so this is VAN, this is VBN, this is VCN. So from pi by 6 till pi minus pi by 6, VAN has the highest value. So D1 will conduct during this interval, and its value is 100 amp, which is equal to the DC current source, because current will flow something like this. And this D3 and D4 will be in off state. And it will remain off till 2 pi. So the RMS value of ID1 we have to find. So the RMS value is 1 by T 0 to T ID1 का whole square dt. So the time period is 1 by 2 pi 0 to 2 pi ID1 is whole square d omega t. And you can write 1 by 2 pi. So you can notice that we have ID1 equal to 100 amp from pi by 6 to pi minus pi by 6, and for other uh, duration in the period is it is 0. So this integral will reduce to pi by 6 pi minus pi by 6 100 square d omega t. So it is equal to 100 by root 3. So when you solve it, you will get 57.73. This is the answer for this question. So please like my Facebook page Triple E Helper. I will post this video on this page. If you want, you can share with your friends. And also subscribe to my YouTube channel for more videos. And if you have any doubt or query, you can either mail me or you can write in comment section of this video.